Whole screen now. All right, so just a couple of things that I forgot to mention the other day. Um, Partially as a consequence of this all being online, I'll encourage you to, if you're sick, not come to class, just so that we don't infect each other. Um, yeah, I mean, you're not banned from class if you're sick, but don't feel an extra obligation to tough it out and come. Because, of course, this stuff you can also look at online. The other trick that I think at the it's coming up. I'm gonna double check that this works before I suggest it to you. Okay, I think there's like a double speed. Yes. So I suggest that you guys, you can probably go back through these at like double speed if you want to save time. I notice there are 8 views. I think 2 of those are me checking that it was up. So yeah. Okay. So starting off for today. The first thing I want to note is that I was not. I was. I did something not ideal in that after last class, I just like minimized this and went on my merry way. And now I'm back at class and I want to do something more. And it's kind of, you can see that in my script. Where is it? There we go. In my script, it's got a red and a little star. That's kind of indicating that I haven't saved what I was doing. It's always a good idea when you stop a work session to save and then close down so that you're always starting from fresh when you're resuming the session. So yeah, I've got some bad practice here. We were just writing, or I was just writing just sort of relatively meaningless stuff here, so I'm not going to worry about it too much. But when we get into actually creating projects and having data and code to analyze that data, I'll be suggesting that you always save and close and then start from the beginning if you have to come back to work on it. But for now, we're going to resume kind of where we left off. So we went through last class, talked about math and logic and assignment. The big thing to remember about assignment is that, well, first of all, names don't matter. You could have something, I didn't give this as an example last time, but I want to now. I could have this, and that's a perfectly valid assignment. So now if I look at the contents of the object called 5, it has the value 6. And similarly, if I said 5 double equals 5, that's going to return false. So the computer doesn't know anything, any English. It doesn't know any semantics.
Except for true and false.
Yes, true and false are special ones that it knows about.
And the alphabet.
Yeah, that kind of annoys me that they bothered. So if you put in alphabet, there's objects. So remember last time I showed you the environment tab? It shows you all the stored objects that you've created. Notice there's nothing in there called alphabet. So I would expect that if I ran this little piece of code, nothing would happen or tell me it can't find an object called alphabet. But if, so that's what did I spell it wrong? Alpha.
I forget how to call it.
Oh, it's letters. If I do letters, there's a bunch of letters that come out. But there's no object called letters in my environment. That's because there's a bunch of like objects that it thinks it's clever and preloads for you just in case you want to use them. That's useful in some cases. For example, all the basic functions are sort of preloaded in your environment, so I can just talk about the print function without defining it in the first place. But yeah, there's some things that are hidden behind the scenes. This is the first instance where we've had, actually, yeah, ignore this for now. I'll get into, this is an instance where we have an output that's multiple things, not just one thing. In this case, letters. I guess I will talk about it now. So letters is, of course, an object in which there's all the letters of the alphabet, and they're actually in order. You notice that when I ask it to show me what's in letters by just typing letters, alternatively I could have said print letters, but I'll just leave it as just letters. It printed them out. The first 8 go on one row, and then the second 8 go on another row, and then the third 8 go in the next row. I told you this number told you how many output items there are, and I was lying. That was because we were doing a simple case where there was just one output, so it was easy to explain at the moment. The numbers over here indicate the index of the item right next to it. So this is the 1th item, this is the 9th item, this is the 17th item, and the 25th item. If I were to resize this window, and run that again, the output changes. So yeah, we'll actually encounter some scenarios with our output where it doesn't look good with certain sizes, so we'll have to resize our windows. So that's all. So these numbers are just for the human looking at it to get a quick glance as to, okay, sort of how many items are there on each row, and what index number is that?
I'm sorry if I'm jumping ahead, but would those numbers in other scenarios display like the size of an array by any chance, or is this something we're not supposed to be talking about?
Yeah, no, those numbers will not show that.
Okay.
No, it's simply the index of the thing immediately to its right in the printout.
Is it possible to do arrays?
Yep.
Okay.
Oh, yep. Yeah, we'll get into those types of things. Another thing that is new is what's with these quotes going on here? Why wouldn't it just be the letter A, B, C, D, E, F, G? It's because I've told you about 2 types of data objects, numbers and logicals. There's also character strings. So if I put anything in quotes, notice my code editor over here is highlighting it in green, coloring it green. If I run that, it'll output over here with quotes around it. And it doesn't matter if it has single quotes or double quotes. If I put just a single quote, that will also be treated as a string. Now, R will automatically output double quotes. So if you notice here, I put single quotes, it automatically converted them to double quotes. That's okay. In fact, if I actually ask, is the object created by a string in double quotes equal to that same sort of set of characters but in single quotes, it will come out as true. Now there's a whole bunch of cool string parsing tools that we'll use to sort of be able to deal with character strings. I'm not going to introduce them now. I just want to introduce you to the idea that there are things called strings, and you can't do math on them. So if I say 1 plus hello, it's going to say, yeah, I don't know how to do that. Question?
So if you didn't have the quotes at all on it, is it going to treat that as like potential variable?
Yeah, exactly. So no quotes. It's going to say, oh, he must be referring to an object, a named object in my environment. It'll look in that environment, not see anything there, and therefore say, hey, I don't know what this is. Any questions? In general, yeah, something that you might be tempted to do is like hello equals 8 to do like an assignment. And that works, I guess.
Were you
That's
expecting it
no.
to not work?
Yeah, that's a little bit annoying that it works.
So you can make strings a variable?
Well, it's just, I guess, a longer way of doing that.
More a less sensible way.
Yeah. So just don't do that. Don't put a quoted string on the left-hand side of an assignment equals. Okay, so double checking. So there's numbers, logicals, trues and falses. There's character strings. And we've already seen also the fourth data type, which is a vector. That's what this letters object is. I'm going to say letters copy equals letters, just so I can have something in my local, I guess it's technically the global environment, but I want an entry in this global environment telling me what letters is. Letters. Okay, so now I've got an entry for this thing called letters copy. If I expand that, and it's telling me, it's giving me a little summary of what the object letters copy contains. And the fact that it says CHR here and then some numbers in square parentheses indicates that it's a vector full of characters, character strings. There's 26 of them. They're indexed by default as 1 through 26. That's what the colon means, through. And then it shows me the first few ones. So a vector can be something that's all of one kind of data, either numbers, logicals, or character strings. So if I tried to create something, well, the way to create a vector, the fundamental way to combine multiple things. So this letters we got because somebody happened to know that that was built into R and was hidden away. Let's actually try to create a vector. I'll say A equals, and to create a vector, we're going to use a function, the C function. So all functions have sort of a character string at the front end and then parentheses. Inside the parentheses, you give what are called arguments to the function. The C function is super simple. We're not even going to really think about it like a function yet because it just takes anything. So we can put the number 1, number 2, number 8, for example. And if I run that line, now I've got an object here called A. There used to be something called A, but it got erased. And this new object called A is replaced there. Now we see that R has seen that all these entries are numbers, so it's a numeric vector, and there's 3 items indexed 1 through 3. And it shows the first few entries. Since it's a short vector, you can see all the entries. What happens if I actually try to create something that is like mixed? So I'll say 1, hello, true. It has turned everything inside to a character. So that's one rule, is that if any of the elements are characters, it will automatically turn all the elements into characters in order to enforce this rule that the list of items in a vector need to be all the same type. So it's turned this 1 into 1 with quotes around it. It's also turned the true to have quotes around it. Come on, show me that one. No, it's not right. Question?
It's kind of a minor thing, but what is the C in the C functions?
Combine.
Combine, okay. I didn't know if it was like combine or create or... Okay, cool.
Yep.
Okay.
Usually functions are a little more verbose in their name, but this is used so often, people decided that C was sufficient.
Cool.
So you can't create mixed vectors. If there's a character in there, it will turn it all to characters. What happens if I just have 2 logicals? If there's a number right there, it's going to turn the logical into a number. So if I have 1 and false, it's turns into 1 and 0. So yeah. What happens if I have, I think a character and a logical, it turns them both into characters. So if there's any characters, everything's a character. If there's no characters, then if there's any numbers, everything's a number. Finally, if it's all just logical, it stays logical. So this being the first time we have a way to create an object that contains multiple things, I should go over quickly before we continue with the idea of functions, because that's one of the main things for today, is when we have, say, this object, I guess A is still there, it's got 1, 2, 8. What if we want to do math with A? So if we say A times 2, what is going to happen? Well, it's gone through, and for each element in A, it's multiplied the element by 2. So 2 times 1 is 2, 2 times 4 is 16, 2 times 2 is 4, and 2 times 8 is 16. All right, any of the math will work out, addition, division, that sort of thing. What if we had two objects? So let's say, I'll just say B equals C 3, 5, 9. So we've got A and B now. They're the same length. If I say A times B, they've just done element-wise. They've done the operation element-wise. So 3 times 1, 5 times 2, 9 times 8. What happens if B isn't the same length as A? Let's A times B again. Put that close to it. So I'm going to run this to create B as length 2. Well, it's given us an output, but it's also giving us a warning message. So let's look at that output. So it's done 3 times 1 is 3, 5 times 2 is 10, but it's run out of elements in B to use to operate on 8, so it's gone back to the beginning of B, and it's grabbed the 3 to multiply by 8, and then it's done. 3 times 8 is 24. I'm not a big fan of this behavior. I think it should yield an error when this happens. Because if you're doing this multiplication and you really intend it to wrap, I feel like that should be a special case because that's really advanced. Most cases where you try to do this multiply by 2 things, I've found it's when I'm expecting them to be of equal length, and I would be helped by knowing if I was mistakenly had one of not equal length to the other.
Can you pad one of them with additional 1s or 0s or whatever? Like on the end?
I'm sure there's a way to do that too, but
To make it so that it doesn't.
yeah,
it doesn't
it's such a
repeat,
niche.
it just-
Yeah, well, yes, to make it not repeat. Yeah, I'm sure there's a way to do that. Like, there's probably a function called pad, but I've never needed to use it. Like these scenarios where not getting an error when you're trying to do an operation on two vectors of unequal lengths are so rare that I think this should be an error. Just be careful of it when you see this warning. Know that that's what's actually happening, is that you're trying to do an operation on two.
But if A had 4 items.
Now that's
in
what
the
I was going to do
element
next. See, if I do 1, 2, 3, 4. Just, the numbers in here are irrelevant. It's just that there's 4 numbers, and B still has what we had it up here, 2. A times B again, so I'll run this one. And this is horrendous to me. There's no warning whatsoever that anything strange might happen. I keep meaning to complain to the original language designers that this is really atrocious, but
Could you compare the vector lengths
Like do
Oh yeah,
if,
yep,
length of A equals
yep.
length of, okay.
Yeah, we can do that sort of nuance to things. Now, happily, the tools we'll be using, it will be very hard to get yourself into a situation where you could encounter these scenarios that most of the time it should create an error, but it doesn't. I just wanted to show you this scenario in case you got these warning messages, what that meant. So, where are we in my... Okay. Oh, another thing kind of left over that I meant to cover yesterday, although I haven't done it yet, just looking through what we did. One thing that if you happen to be going through these examples and wanting to write the code and make notes to yourself about what the code is actually doing, the hash mark, the number sign, is for comments. So hello. So that's the useful way to put comments to yourself, notes in your code. If you actually try to run that line, it will get put into the console, but R will see that there's a hash at the beginning and it will ignore it. There's no consequence to what's going on there. So if I actually have in hash A equals 10 and I run that line, so I can see it got copied over there, but A is still this original thing that it was up here. So it's ignored what's on that line. There's no computation done after it encounters a hash. One neat thing about the RStudio GUI is there's a special kind of hash that soon we will talk about functions. So I'll make this a little bit bigger. If you wanted to have little headers, like sections in your code, and you wanted a little table of contents to quickly jump from section to section, if you press the minus sign 4 times, 1, 2, 3, 4, right down here, there's now a little thing that all it has is that one entry. So if I'm going to jump to the top and I'm going to say this is the top 1, 2, 3, 4. Now I have 2 things. I'll put here is a middle comment, 1, 2, 3, 4. So now I can jump to the top, to the middle, and back down to the bottom. So that's super useful if you've got really sort of logical chunks of your analysis. So reading in the data, pre-cleaning the data, running a model on the data, visualizing the model. You can have those as separate sections, and if you use this specific set of characters in your comment, it will make a little jump toable entry in a table of contents here. So that's super useful. All right. So functions. So we've seen a couple functions already. I've shown the print. Excuse me, I'm violating my rule about not showing up sick. So we've seen the print function. That's pretty self-explanatory, except for if you're completely new to all functions whatsoever, in which case I'm pretty sure I mentioned that all functions start with some character string and have something in parentheses, and the function will do something with the thing that you're giving it. So inside the parentheses are what are called arguments. Print is taking a single argument here. It's the object A. So we as the coder are giving the print function the object A. Print will look at the contents of A and do something with it. Now, the print function happens to do is print out just the contents. Other functions do other things with the content. So if I had a scenario where I'll use the round function. So the round function I happen to know about. if you had no idea what the round function was about, you would search it up on the help tab. So there's help up here in the tab, and there's 2 search boxes. One of the one you want is the one outermost one. If you say round, enter that, it comes up with a single page. Sometimes if there's multiple hits on a given search string that you put up here, you'll get multiple pages. But round happens to be a function that is sort of only matches one thing. So you get a page for rounding of numbers. Now this actual page gives help for multiple functions because those multiple functions kind of form a family that all operate in the same way. So there's round, it gives a thing here, but it also talks about ceiling, so that's where instead of rounding you just always round up, floor, which is you always round down, trunk, which is you just sort of erase a number instead of going up or down, round of course, and signif is kind of like trunk, or it's kind of like round, but it figures out the number of significant digits from the period. Round cares about where the period is. Signif talks about just the number of digits in the output altogether, including to the right, the left of the period. Question?
So does trunk only take off like 1 digit at a time? Or?
Well, so that's the question. How do each of these functions work? So learning these documentation pages is part of the learning curve that you're going to experience. These document pages themselves have variability in how helpful they are. So usually they have a common structure where they have, right at the top, it's got a thing called round. In the squiggly parens there, it says base. That's because round is a function provided by one of the packages that come pre-installed with R called the base package. That's why it's available right away. We don't need to do anything special to load in the round function. It will usually have a title of some sort and then a description of what the function does, or if there's multiple functions, a description of what each of the functions do. More useful is the usage section and the arguments section. And usually you have to look at both sections kind of simultaneously. So the usage section will give you a view of the arguments and what their default values are, but not what the arguments are doing. The arguments section tells you about what the arguments are doing. So let's just look at the entry for round. It says there's 2 possible arguments that you can give to round. An argument called x. So arguments are always separated by commas, and arguments are named. So this argument is called x, and this other argument is called digits. And this little equals 0 bit means that this argument has a default value. So that you'd actually, if you wanted it, let me actually talk about the argument, what they mean first of all. So x can be anything. It can be a single entry, a number, or a numeric vector, I guess. Those are the 2 options. So not anything, just number or a vector of numbers. But a vector could be of any length. And it's going to go and it's going to go through and round each one. Digits is an integer indicating the number of decimal places or significant digits to be used. So it's the number of decimal places to be left over after you do your rounding. So if you wanted to round to 0 decimal places, so truncate so that there's no decimal places, then you actually could write in, let's actually give an example. So if I say round 1.6 digits, and actually I'm going to be really explicit. I'm going to say x equals 1.6 and digits equals 0. So in previous functions, all the ones that I've given you, well, print took 1 argument, C up above took multiple arguments, and I separated them by commas, but the arguments weren't named per se. I just gave numbers in there. Here, I've got multiple arguments, so there's a comma, and there are multiple named arguments. So I say x equals 1.6, digits equals 0. So I can run that, and it's going to round to whatever this x value is to have 0 0 decimal places. A default value, so here it's showing me what the default value for digits is, that there is a default value. Notice there's no default value for x. X is just there. It's not x equals something. There isn't. So when you see digits equals something, that means that there's a default value for digits. The default value for digits is 0. So if I know about round already and I want to save time typing, I know that round's default is to round to no decimal places. I could save myself some typing by just running that. In general, well, it's kind of up to you to decide when you feel like you know the functions enough to omit putting the defaults. Some functions just have so many arguments that you, by definition, have to accept a lot of defaults. But one sort of theme I'll have is that where you can be more verbose, it tends to pay off in that it may take a little bit more time to type. It will be a lot easier for you 2 months down the road when you have to come back and try to figure out what you were doing in the first place. Something simple like this, I think round, it's pretty intuitive that by default it's going to round to just no decimals but if you wanted to round to some other number of decimals, you'd put a number there. So if I had much longer number and I wanted to round so that it's 2 decimal places, I guess it's 6.9. Notice that actually it did round it to 2 decimal places, but those 2 decimal places are 1.70, and the printout has rounded it, has just omitted those last things.
Is there any reason that the printout would omit something like that, or is there any way to get that back?
There is a way. It's in the options. I don't want to delve into that right now. Yeah, because let me actually look. So if I do this like that, yeah, so that's more what I was expecting. But if I were to store that number away, yeah, well, 1.7 is the same numerically if I were to do math on it as 1.70. If you want special printout for reports and things, we'll deal with that quite a bit further down the line. So the core things to get from this is that functions can take multiple arguments. Those arguments could be named, and those arguments might have defaults. It actually doesn't matter the order in which you put the arguments. So if I wanted to do digits equals 2, comma, x, blah, 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 it's going to give me the right output. It's also the case that you don't need to name the arguments. No, I guess. Well, you don't need to name the arguments. It will infer that if you don't have names there, it will automatically think that it will see the order that it's being defined as in the help documentation. It will assume that the first thing you give it should be supplied as the value for the first argument here. And the second thing you get it is the thing that you want to supply as the second argument here.
So order doesn't matter if you define it, but it does matter a lot if you don't.
Exactly. So this is why I always suggest that you actually always name, because it's easier to remember the names of these arguments than it is to remember their order. So the meaning of each thing you're passing it, well, you're passing it, so you should have a sense as to what you want the function to be doing with that thing. But it's harder to remember, particularly for longer functions that take many more arguments. It's harder to remember the order that the function expects them to come into. So it's a good idea to always name the arguments. Now, round is a function that just takes 2 arguments, so it's pretty compact. For a lot of other functions, though, there may be a lot of arguments that they can take. So one thing that I also suggest as a best practice is to use whitespace to make your job as a code reader easier. So what do I mean by that? So whitespace is an enter, a space, or a tab. I use enters and tabs myself. So when I've got a function, let's say I want to just arbitrarily, I'll assign the result of this function into B. So what this is going to actually do, well, actually, I'm going to take that off and talk about that after. Okay, so I'm going to use the round function. I know that it takes multiple arguments, so I'm immediately going to add a new line. Now, the editor is smart enough to know that if I add a new line after making a parenthesis, it will tab in for me. So it's actually added a tab character right there. So then I'll say x equals 1.642. And I could just say digits equals 1, and that would work. But I actually want to put each argument on its own line. And another thing, I could just, it doesn't matter where I put the break, either before or after the comma. So I could do it like that. But I actually like to put, even though it looks a little funny at first, I like to put the comma at the beginnings of the lines. And I also like to add a little space in between the equal sign. Again, this white space doesn't matter. It's just for humans reading it. It'll come out to the same answer. It's just a little easier to debug your code and see or understand what you're doing a couple years down the line after you come back to a project and you want to replicate it or figure things out. So can anyone guess why I like to put the comma at the beginning of the line?
So you can make sure you actually remember to put it in rather than having it buried at the end of the line.
Yeah, exactly. So for years when I was programming, so this is actually an unusual practice. I haven't seen anybody else do it, but for so many years I battled with errors that came down to me forgetting to put the comma in. So if I just do it without any commas whatsoever, it will give me an error that's hard to see what's going on. So first of all, it gives me an error and then it has a parenthesis. So it's hard to see what's going on. It's not telling me, hey, you're missing a comma.
I love the unexpected parentheses.
Yeah, exactly.
Parentheses.
Yeah, exactly. Yeah. So, and because each line might have like a variable length, it's hard to see that there's anything missing at the end of this line. But it's if you adopt the practice of expecting to see a comma at the beginning of every line, except for the first. One thing that I sometimes do is I space in the first one too. So if I expect to see a comma at the beginning of all the lines, it's a lot easier for me visually to notice that, oh shit, I forgot to put the comma at the front. So I highly suggest, you don't have to, but I highly suggest it'll make your life easier to put commas at the beginning of lines. All right, so that's some best practices in formatting functions. It's a little silly for this particular example of rounding a single number because it can be done pretty human-readably on a single line. But some of the other functions that we'll be using will have arguments that it will be a lot easier for us to read what's going on if they take multiple lines. Okay, so round functions produce results. You give it input, it spits out output. By default, if you don't put that output anywhere, it prints it out to screen. So that's what we've been seeing this whole time. We supply round with some input, and it spits out that output. We're not catching it, so it just arrives on our screen. If we want to put that output into something, we can use our assignment. So I'll just run that. So round has done its computation, and then put the result of that computation into the object called A. Now we can use A for other things. So if I say print A, we can see it. If I say A times 2. So round is an example of a function that just produces one output. If it produces as many outputs as you've given it for input for this thing x. So I'll give another example. A equals round, x equals c, 2 point blah blah blah, 3, 4 point blah blah blah. Yep, put a decimal there, and I'll say digits equals 3. So I'll run that. One nice thing is that if you've got a big chunk of code like this, and you're running the preview version of RStudio, you can click anywhere in this chunk. So I finished typing, and I can, once I'm done typing there, I can do Command Enter, and it sends the whole chunk. It figures out how to go back up to the first where I started and complete that whole chunk. So that's one nice feature of the preview that I like. So now A, presumably, is still, or it's taken this entry of 3 things, and A should be the rounded version of those 3 things. Question?
How did you copy that over to the
Ah,
console again?
I just Command Return. So I
see.
just had my cursor somewhere. It's the same thing as selecting all of it and hitting this Run button,
Okay.
or selecting and hitting Command Return on the whole selection. If you're anywhere inside, because R has figured out that, oh, we're inside a function here, so Mike must intend to select the whole line, or the whole function. And oh, one other thing that I didn't point out is, even though we've split this function across multiple lines, if you notice you hover your cursor near that parenthesis, it actually visually shows the preceding parenthesis, and ditto if you hover over the first parenthesis, it shows the closing parenthesis. That's really useful for when you are writing things and usually it automatically inserts a closing parenthesis as soon as you do an open parenthesis. So if I start typing print, and I just put an open parenthesis, and it automatically inserted that closing parenthesis. So if I say print A, so usually it's hard to forget to put the closing parenthesis, but if you lose track of where the closing parenthesis is, it should visually highlight it for you if you put it near the opening and vice versa. So functions can take, so the round function, if you give it an input of length 1, it spits out an output of length 1. If you get an input of length 3, it spits out an output of length 3. Other functions perform differently. So it'll be up to the function what it spits out. Question?
Remind me, what's the C doing there? Like, you didn't have the C and it was just x equals those 3 values? Or is it gonna
So
recognize those values?
round is structured to expect just 2 things separated by a comma.
Right,
So
confuse it,
yeah, it's going to confuse it. It's saying, okay, I found an x, I found a digits, but what are these other things as well? Let's actually see what is the error that it's going to give us. 4 arguments passed around, which requires 1 or 2. Okay, you can actually think of this as I've actually done 2 functions here. I've done a C to create sort of a vector to combine these 3 things, and instead of storing it away in memory, I immediately gave it to x. I could have said b equals this, and x equals b. That's the same thing. A little bit more verbose. It does require me to think to create a number or a name for this temporary object. I'll actually show a trick. Down the road, we'll see a trick to not need to create this temporary thing B to then use round. But right, I was saying that rounds will just round each element of the input that you give it. So it's going to have the same length of output as the input. There's other functions that will in some way compress what you gave it. So mean, for example, is something that will compress what you give it. So if mean, let's look up the help on mean. You can look up the help by typing in this help area here, or you can type $me and the name of the thing that you want to ask about. It's the exact same as doing an explicit search up there. I'm used to just typing $and the thing that I want to ask help about, so you'll see me do that more often. So we'll look at the help here, usage, mean, x, comma, dot, dot, dot. You'll see this often, and then it shows you this default S3 method, mean, x, comma, trim equals something, NARM equals something, comma, dot, dot, dot. So this is a little bit more complicated function in that it accepts a whole bunch of other, well, it accepts some other arguments, including something called dot, dot, dot. You don't need to care about that right now, what this dot, dot, dot means. This dot, dot, dot means that you can give it more arguments than it has specified here. It will never give us that error that we encountered above, 4 arguments passed, but requires 1 or 2. It will accept other arguments and even other named arguments. It will just ignore them. There are deeper benefits to having a function that accepts arbitrary other arguments that we're not going to encounter. So for now, the big thing for mean is that it's got one argument called x. X is an R object. Usually it's a vector that contains numeric values. It can also be dates and time intervals and things like that, but we're not going to bother with those. There's 2 arguments that come with it by default. Trim, so the fraction of observation to be trim at each end of x before the mean is computed. So it will actually sort what's in x, and if you say give it a vector of length 10 and you put trim as 0.1, it will toss the first and last item. If you had trim as 0.2, it'll toss the, wait, yeah.
Why don't we try it?
Yeah, let's actually try. So, all right, let's create an object, a equals, and I want to create 10 items. So we can just do C, 1, 2, 3, 4, 5, but that's a lot of typing. Quick trick, 1:10 is the same thing as doing C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we say print A, it's the numbers 1 through 10. Okay, so let's use mean on it. Mean, let's just say mean A. We could have said mean x equals A, but that's implied in this case. You don't need to name them. So the mean of these 10 numbers is 5.5. Let's see. If I say mean x equals A and trim equals 0.1, I'm breaking all my rules here. I'm not putting them on separate lines, etc. Oh, the mean is not going to change as we change this.
Why don't you make it like to 12 or something?
No, as long as it's symmetric, it's not like as long as there's equal spacing between each one. So let's get some new numbers.
Yeah.
It's not 1 through 10. Another function that is going to generate data, runif. Unif. There we go. So runif. Let's look at that one. Well, it's in a family of functions for the uniform distribution. Here's its usage right down here, RUnif. It's got a thing n, min equals 0, max equals 1. So what is n? Number of observations. So we'll get into this more, but whenever you see an R and then like a probability distribution, the R means a random sample from that probability. So we're going to get a random sample from a uniform distribution. N is how many samples we want. So let's do 10, for example. And we'll accept the defaults of min equals 0 and max equals 1. So RUnif 10 should give us 10 random samples. So if we get the mean of all those samples, 5.2, let's do a trim. See, the way for me to check this, you might have different numbers, first of all. Yes, you will have different numbers. There's a way for us to make it so we all get the same numbers. I'll show you that now, since we're encountering it. So there's a function setSeed. It accepts any number as its single argument. So let's say setSeed equals 1, and you don't. It doesn't return anything. If I select that and run it, nothing kind of prints out there. Additionally, we're not like assigning the result of this into anything. It just does something. This is an example of a function that has side effects. It affects like how R is going to do computation in the background. And what that does is it makes it so that if you then generate some random numbers, you're starting at the same sort of point in a random shuffle process. So now if we all run this, we should all get the same numbers.
Looks good.
Certainly all the Macs should get the same numbers, and all the PCs should get the same numbers. It's possible if you have like an old... I've encountered scenarios where the random numbers don't match up depending on what specific processor you have on your computer. But in this case, I'm pretty sure it should work. All right, so we've got some random numbers. Print them. We can compute the mean. Everybody should get that mean.
I'm on a PC and they're the same as yours.
Okay, great.
So
So if we trim 0.1, it gives us one number. If we trim a little bit more, all right, so we're trying to infer what is going on with this trim argument, how much it's going to trim. We're getting a little bit into what I guess I didn't intend to show you yet, but it doesn't really throw things off to show you. So how would we go about checking how many items are being trimmed? Anybody have any idea?
Is there a function called trim?
just try. There isn't.
Set the new, like,
Or
put that mean
yeah.
set as a new variable and then read out that.
Okay,
No, it wouldn't.
we can
Sorry.
we could just see it right there. Like that's
Yeah.
so that's the mean if you don't do any trimming. This is the mean if you trim equals
Yeah,
0.1. It's the mean if you trim equals 0.2. But
And since we have 10 values, it's 0.1 is 1 off of each end. 0.2 is 2 off of each end.
okay, so that's a theory. How could we check that theory?
Oh, I mean so trim can only be 0 to 0.5, which to me would imply if you did 0.5, it would just take 50% off each side, and you
Yes.
get nothing.
Yep. Yeah. Okay. Any ideas how we would confirm that theory though?
You could
Like
go
it's pretty
into
intuitive.
A and get rid of the
Aha.
first two
Yes.
values. And then
All right.
check
So I haven't told you anything about like either editing what's in A or like indexing into A. So A is a vector. It's got 10 items. In the same way that these square brackets sort of tell you about what index is immediately to the right of them in the output, you can use square brackets to index into A itself. So if I want to talk about the third element in A, well, I can see it right there. It's 0.57, whatever. But if I want to do computation just on that element, I can put A square bracket 3, and it's going to give me that third element. Similarly, if I want to say A and get 2 elements, say I want to get the second and 8th. Well, I want to put something here, but I'm not putting a single number, I'm putting a vector. And how do we create a vector in the first place? Is by the C command, the C function. So if I wanted 2, 8 as the thing that's selecting setting the index of what I want to grab out of A, that will grab the second and 8th item from A.
So only the C function can make vectors. You can't just assign any old.
Now, yeah, no, you have to. Now I could have created something, say B equals C to 8, and then said A indexed by B. Could have done it that way. But no, if you want to create a series of non-sequential numbers, you have to just see them together. That sentence implies there might be a way to do a series of sequential numbers more easily, and I actually showed you that above, where if you want to grab, say, the first 5, you could just say A, and then in square brackets, 1:5. Run that. That grabs the first 5. All right, so now how might we test what's going on with this trim business with our knowledge of indexing on A?
I did, I made 2 additional variables. I made E and F, so E equals mean of D trim 0.1, and I did F equals mean D of 1 to 9,
Aha,
2 to 9,
yes, okay.
but they do not end up being the same.
Interesting. Okay.
They're quite a bit off for me.
All right, so I'm going to look at what is the mean of A, look at what is the mean of A when I trim is 0.1, right? Yeah, so that should be 1 item. And I'll also look at the mean of x equals A, and there's 2 to 9, right? That's if we took off the first one and took off the 10th one. And I don't want to trim now.
It's probably not working right because it's not, when you do the R unit, it's not ordering it sequentially.
There we go.
Bias, so you're taking
Yeah,
2
okay.
points at
So
any point.
that's exactly what's happening.
Oh.
So what?
Figure out how to order them sequentially.
Yes, so we need to figure out how to create a sorted version of A.
Cool.
Yeah. Anybody want to?
Could be the sort function.
Oh, hey, that works.
Yep.
Just set it up
So
as
there
variable.
is a sort
becomes
function.
Sort A.
There's a sort function. It takes one argument x, and then some other defaults that we won't really need to care about because it's a pretty self-explanatory function. So I'll create a new object, sorted A equals sort A. So if I say sorted A 2 through 9, will it give us, oh, I didn't create it first. So is that the same as mean of A trim equals 0.1? Yep.
So trim by default organizes everything
Yep.
and then takes off the whatever number values
Yeah.
that you want. Okay.
Yeah.
It'll trim the highest and lowest values.
Yeah.
Mhm.
Rather than
Where your
just
vector is in the sorted orders. So
Yeah.
obviously the highest and
Got
lowest.
right. So actually, yeah, maybe I'll try to engineer more of those scenarios and find out how to troubleshoot areas. All right, so that's your first sort of exposure to functions, and the big takeaways is that functions have arguments. They can be named. Good idea to put them all in the same order. You can have functions that like do a bunch of operations on the input. So this, for example, sorted them and potentially trimmed them, and then computed a mean. We'll learn a bunch of cool functions as we go. There's a bunch of functions built into R already. So we've seen print, we've seen mean, we've seen C, we've seen sort. Any other ones that we've seen? Set seed.
Argue.
Yep. RUnif. So all of these we've been able to just start using right away. We haven't needed to do anything special to use them. There are some scenarios where somebody else has written a function, and we'll talk a little bit later about how to create a function and when you might want to create a function. But some people have created some useful functions that we may want to use. If they've been particularly helpful, they've bundled up the code to create the function into what's called a package. Usually a package contains many functions that somebody has designed to sort of be a family of useful things. We would want to be able to install packages. So there's a large ecosystem of R packages. I'm going to bring up my browser. So we'll go CRAN. So this is back to that page that I showed you on our last day. Over on the left-hand side here, there's a bunch of links, one of which is packages. There's about 10,000 packages. I feel like there should be more. I thought I saw a blog post where it broke 10,000. But so obviously, you don't want to look at the table of available packages sorted by date or sorted by name. You probably are going to encounter packages more through what you read in textbooks and maybe online postings and things like that. There is a task views area that lists a bunch of general like areas of data analysis that then themselves have associated packages. So the first entry, Bayesian. And then it lists, with a little bit of a description of each, a bunch of the different packages available. Let's see, where's Stan? Yeah, so this is actually a big group because Bayesian data analysis is a big thing. Well, there's Stan right there. Refers to Stan. We'll be using Stan. Let's see, anything else? For psychometrics. So lots of advanced item response theory packages and this is mostly multivariate type stuff. So you can look at these task views, but I'll be telling you about the packages that are most useful as we go through the course that you'll need. So you probably won't need to like search out what package do I need for this particular thing so much as you'll need to know how to install packages. And install packages in RStudio. Again, most things in R can be done by code. So the way to install a package by code, if you know the name of the package, let's say easy one, car. Install.packages. If you know the name of the packages, so install.package is a function that installs packages. It goes and downloads from the web, so obviously you need to be connected to the web. you put the package name in quotes because it's a character string. So you say install that package's car. It's okay if you hit enter and you run that, but I'll also show you the other way, the point and click way of installing packages. Most of the time I encourage you to do things by code, but this is one instance where point and click is kind of okay because installing a package is something you only ever do like once or maybe every time you update your R. So it's kind of okay that it's not like replicable. So clicking packages, this packages tab, notice there's an install little dialog there, or button, which brings up a dialog, and you can say, I want the car package. As you start typing, it's searching the entire library of 10,000 packages to match up. So there is something named car, so we do want that. It's got some default stuff here, install to library, just leave that, whatever it is, install dependencies. So if you click install, it actually just ran the same code as I started typing here. So that shows you that the point and click method is just doing the same as what the code is. So a download, and it's hard to kind of see, but it did install. It successfully installed. Now, to use the car package, again, if I want to do it in code, and this is something that I do suggest you guys do by code, you again say, I wish it would be like load package car, but the function name is called library. So library car. And what that does, the library function will go, it will find the car package that's being installed on your computer. It will then go get all the functions that the car package provides. The author of the car package wrote a bunch of functions that are useful for data analysis, and having run this line, those functions are available now to use.
And we have to run the library function every single time.
Yes, exactly. So you do have to do this every time you start a new session. So it's a good idea to put this at the very top of your script to indicate to yourself and anybody who comes and looks at your code later what are the packages that they might need to install in order to even run your script, but also to have it load those at the very outset of your analysis.
I haven't installed, but if you put like question mark car, can you see like how do you
So-
know what it does?
Okay, so having loaded it, let's do question mark car. So yes, it worked. So if you just do question mark car, it actually started auto-completing to car dash package, which should bring up the same page. For this particular package, it worked because the author followed best practices and made it so that there's like a landing page for the whole package. This help page will hopefully describe what the package is about. It's not great, actually. Function data set to accompany this textbook. You can scroll down and look at the index. This is like it's a table of contents for all the functions provided by the car package. So there's a whole bunch of things. There's some ANOVA associated functions, etc. So usually when I have you guys install a package, I'll be describing the functions that are useful from that package, so you won't need to delve into finding what functions a package provides and why they might be useful. But if somebody says, oh, check out the BRM package, and that's all they tell you, this would be how you go and see, okay, what functions does it provide. So I told you that this is the way to load packages by code. There is a way to load packages by point and click. So again, I showed you the install packages by point and click. There's also a way to load packages in that all the packages that are already installed in your computer are in this list right here. Notice car has a checkbox check by it. That means that it's already loaded. So if I want to load a different one, say the cluster, I can just check that. And it's the same as if I typed here library cluster. I suggest that you do the code way of loading libraries rather than the point-and-click way of loading libraries, simply because it's so critical to have the libraries loaded properly at the beginning of your analysis. One thing that you can ease your typing is that when you're loading libraries, you actually don't need to use the quotes. I've started to put quotes around just for consistency in everything that I do, but it's okay to not have quotes around the thing that you're loading in. When you're installing things, you definitely need the quotes, but when you're loading in a package that it already knows about, you can actually just give it the string cluster without quotes, as if there's an object called cluster. It will see that there's no object called cluster in the environment and go look in the package names for something called cluster. There's reasons why that's actually a bad practice, and maybe it's a good idea to always put quotes around it. So I'll try to put quotes around it all the time. You might see code that I've written long ago that doesn't put quotes. Certainly not everybody that writes code out there bothers to put those quotes.
So this means, for example, if you have an object called cluster.
Yeah, let's actually try that. I'm going to click help, or not help, but packages, and find one that I haven't installed yet. Broom is one. You guys might not have Broom yet because it's part of a package set that I haven't had you install yet. So let's say Broom. Broom isn't loaded yet. I'm going to say Broom equals tidy. So I've created something called Broom. It's something called tidy. Its value is tidy. Now, I predict that library is smart enough to know that when it finds this thing called Broom and sees that it's just a character string, that must not be what I mean to use, and it'll go automatically go find the proper thing that I might refer to, which is the package called Broom, and that is correct. So it's clever. I would suggest that it's maybe overly clever.
What would happen if you set, like, for example, create an object called brew, and brew equals boot in quotation marks, and you looked up.
Yeah, that would be a really nefarious way of doing things, of intentionally confusing yourself. So the example, yeah. So there's a brew package and a boot package, and the suggestion was I'll create an object called brew equals boot, and say library brew. Whoops. Is that going to load the boot package or the brew package? I actually genuinely don't know. And it loaded the brew package. Okay, wow. Yeah.
Now we know.
So
What if
good.
it had loaded both?
Yeah. So yeah, so it's a good idea to always put quotes around it when you're
I
loading
think it's
things in.
just, I just look at the library function, and the first argument is just package.
Yeah.
So it's not even, it's asking for the name of the package. It's not
Yeah.
asking for a name or anything. And then it'll look through the library.
Yeah, it's
asking for the package.
yeah. I can understand the motivation. It just can run into issues. I mean, you kind of have to be intentionally obtuse about it to cause this error, but the fact that you're allowed to cause that error is not good to me. All right. So with the last little bit of time I have left, we're mostly going to be dealing with packages, functions from other packages, either functions that have been built into the base set of packages, or the from what are called contributed packages you have to actually install. The big one is the tidyverse package. That's a meta package in that it actually brings together a whole bunch of other packages that are useful. That's the author of the tidyverse packages is the same author as the textbook that I have you guys looking at. The R for data science. Okay, but There are going to be some circumstances where you might want to make your own functions. So when might you want to make your own function? If you find yourself typing the same code over and over in the same sort of project, it probably means that you want to. Let's imagine that mean function didn't have the option to trim. So we wanted to create our own function that did, or at least we say have a bunch of objects, each of which we need to trim. And so I could say, okay, here's my A object, it's our unif 10, and I'll have a B object, our unif 8, and somewhat annoying. I usually try not to name objects C because there's a C function. I actually find that a little annoying that there is a C function because it means that my typical naming scheme is thwarted. But it actually doesn't hurt. You can still use C as both the name of an object and the name of a function. I'll show you that in a little bit. So I've got 3 objects, and I want to get the trimmed mean for each of them. Okay, well, I would have to say, okay, sorted A equals sort A, and mean sorted, actually here, and I'll even say trimmed A equals sorted A 2 through 9. And then finally, I'd say mean of trimmed A. So that's how I would get the sorted mean for A. Now, if I want to get the sorted mean, I'm going to make this bigger, Now, if I wanted the sorted mean for B, I could copy this line, change the A's to B, copy this line, change the A's to B. I'd have to then look, okay, how many items are in B? So 2 through 7 now. And then mean trim that.
We have trimmed B equals sorted A.
Oh, yeah. So copying and pasting code, I already made like a mistake that I maybe wouldn't have caught. Not a great idea. If there's some sort of, you can kind of see there's something generalized across these two cases, getting the sorted mean for A, or getting the trimmed mean for A and B. We have to do something slightly different each time, so there's a little bit of nuance, but that's what functions are for. They allow you to take input and do a computation on that input, possibly dependent on the structure of that input. Also, certainly possibly dependent on the number of or whatever arguments you provide to the as part of the input. But then do it in a way that's consistent across the different inputs. So instead of typing all this and possibly making typing errors, and certainly if I see that I have to do it again for C, I would notice, oh, I've done some repetition here, so it's probably a good idea to just make a function instead. So to make a function, we're going to use the function. So the function so we are telling the function what to accept as arguments when we pass arguments to the function. So if we want to accept an argument named x in our function we're making, we put an x right there in this function. And for now, that's all that we need to do, actually. We just want a function that will take the trimmed mean, and we're just trimming one item off the end, each of these cases. So we're creating a function with a single named argument called x. To define what the function does with its input, you then put the squiggly brackets. It's shift and the same key as the square bracket key. Now, usually a function does more than one thing internally. Certainly we've got more than one thing going on in each chunk of code here. So what we want to do is use each computation that's going to be done is going to be done on a new line. And it automatically inserted that tab for me. So what this function is going to do is what's inside these squiggly brackets. So the first thing it needs to do is create an object that's the sorted version of its input. So sorted x equals x. Oh, sort x. Sorted, trimmed.
Can you use a comma?
So no, we're just, this is, so inside these squiggly brackets, it's like you're just writing code, that you're just doing operations one at a time. So in the same way that you just use a new line to do this operation and then this operation outside the squiggly brackets, inside the squiggly brackets, it's the same thing. The squiggly brackets create like its own little private R session. And so you can just write code as if you're doing your own private R session there. So we sort x, we trim x, but what are we going to do here? We had 2 to 9 for the case of A, and 2 to 7 for the case of B. So what are we going to choose to do here
So
if we want something that's going to generalize?
2 through length of x minus 1.
Beautiful. Is there a length command?
Yes.
All right, so there's a length command. It does pretty much what you expect it to do. We can triple check. We'll say length of A is 10, length of B is 8. All right. So I'll make these both big again. So it'll be 2 through, and I'm going to put parentheses because I'm not sure how order of operations go with the colon. I'll say length of x minus 1. So that, regardless of the length of x, should get it, toss the first sorted element and toss the last sorted element. And then finally, well, up here we have these two. We define sorted B, we define trimmed B, and then we just run a mean, which in theory would print a screen. Here, a function, if I say mean trimmed x, it's going to what's called return this value. Just like mean returns a thing that if we don't catch by putting it into an object, it will just print a screen. The function is returning this thing that's returned by mean. So the last little bit that we need in creating this function is to name it. So I'll name it something useful. Trimmed mean equals that. So this little bit creates the function, and R is going to see that there's an equal sign, so it's going to take the object resulting from creating defining the function and put it in an object called trimmed mean. So now when we can actually use this function trimmed mean by using its name and then putting parentheses next to it. So trimmed mean for A. I didn't run this bit. Gets us out that, which I should actually triple check. Is it the same thing as what we had up here? Yeah. So we get the same values. Trimmed mean for B. Double check that I get the same values as I did up here. So you've saved a little bit of typing and certainly made it so that you're doing the same thing to both A and B. Here, by copying and pasting and then trying to modify it to suit the scenario, you could have had human error in doing that. We can additionally now have trim mean for C. So that's the basics of creating a function. One thing that I want to get across, though, is that let me ask you this. What happens if I say x equals, let's say, 1 through 10. And then I say trimmed mean A. What's going to happen?
I don't think anything will happen to the function, I mean.
Yeah.
It'll run X.
So, but don't I have x? Don't I talk about x in here?
But that's in its own special.
Aha! Yes. So I said earlier that the function creates its own sort of special place where it does computations, and it only gets to see what you give it. So even though x exists now outside in my environment where I'm doing computations, as soon as I run this function, which implicitly is saying x equals a, it creates its own little environment where all that exists is the object called x, whose value is whatever was inside a. And even if I have, I'm going to add a little thing, x equals, or actually, after I sort x, I'm going to say x equals x, or I'll say x equals 100. So I sort x, I then inexplicably assign the value 100 into x, so overwriting whatever's inside x. I then do the regular trimming of x, of the sorted x. Oh, that's not going to work here. I'll have to say for this, well, once I'm done sorting and trimming x, I'm going to overwrite what's in x, put inside x 100, but still return this mean here. If I run that, so defining the function, now running this function. Okay, well, we've returned the trimmed version of the input, which is A. What do we expect to happen?
I think you just reselected x equals 1 to 10 again when you printed trim mean x equals a.
Oh, you did.
Yeah, no, I intended to do.
Oh.
So inside the function,
Oh.
I accept whatever the input is, assign that to x, and then sort it, trim it, arbitrarily overwrite the object that was created to accept that input, and put in it the value 100. And then finally I return the trimmed mean that I intended to get. So the question, and so that defines the function itself.
Yep.
This code, like the computation, no computations happen until I actually run the function.
That's not going to change anything because you're returning the line above. Right? Before you change it x to 100, the returned is that trimmed x, so
Well, I'm returning trimmed x.
so it's just going to run the trimmed x line, not.
Well, it
change
will
that.
return. It will actually run all these lines. So I could even say print x right there. And if I'm going to create an object accepting the output of this trimmed mean as and put it into out. All right, so I define this. I create something called x that's 1 through 10 in the global environment. I run this function. So the fact that it printed out x, even though I asked it to assign the result of the function back into out is expected because I actually have an explicit print command inside the function before I do a return. So, but this is demonstrated also that these two lines actually did run inside the environment that the function knows about. X got set to 100. But what should X be out here?
1 to 10.
Any guesses? Who thinks it's going to be 1 to 10? Anybody not 1 to 10? So, some uncertainty. It's still going to be 1 to 10. What happens in the function stays in the function.
When you did print out, what happened to the mean the second time?
Oh, I don't think I ran print out. Yes, there we go. So that establishes that indeed it returns this value that got then put into out.
And is it arbitrary which letter you use for creating the function? Could it be like A or B?
Exactly, yeah. X is very common if it's a single value input or a single argument input. But yeah, I could have put any name here. Z, Q, some long string.
Two questions. The first is, is there a way to make a function that would alter the global environment?
Yeah, that's getting into pretty advanced stuff.
Okay.
That's called side effects.
Okay.
That would do it. This weird double-headed arrow is a way of jumping out of the isolated environment that this is talking about. Usually if you're doing that, it means that you're doing something wrong. If you feel like you need to do that, there's probably an easier, better, less error-prone way of doing things.
Okay.
So.
And I guess I missed or misunderstood why you had after we did all that the trimmed mean x equals a instead of just x or a.
Well,
X?
I had a named argument x,
Okay.
and so that's why.
Got it.
Yeah. So I was
Okay.
pointing out, first of all, that having an argument named x, despite the fact that you have an object named x in your global environment, is okay. Maybe a little bit human confusing, so that might be better to name your variables a little bit more less succinctly, but it's okay. It's
Okay.
not going. The fact that you have this in the outer environment isn't going to affect what happens in the inner environment. Additionally, what happens in the inner environment doesn't affect what x is after you're done all that computation.
If you had done that, if you ran trimmed mean of just x or just
Then
a,
that would
what
accept.
it?
Yeah. Okay.
Okay.
Well, it's exactly like what we have up here.
Okay.
It implicitly assumes that you must mean the only named argument that's there.
Okay. Okay.
Yeah.
Cool.
It's like what we encountered above when I said that you can round
Okay.
and not put the names. It will assert the names by looking at the order.
Okay, I didn't realize that was just sort of showing like this is what it assumes you're doing, but you can actually type it out anyway
Yeah.
if you want. Okay.
Yeah.
Okay.
If we had like a really long function, like there's no way to kind of see the memory within it, like where we can in the environment.
To step through the function. I'm sure there is. There's a debug. I've never used
Well,
it.
you can, once you create a function in the environment, there's the function, you see your list of functions, and there's a way to go in and look at the written function within the global environment.
Yeah, you can see that.
Like to the right there, the little scribe on the right will pulls out your function.
Yeah, it shows the code for that function, but it doesn't show like the memory environment, like as you run it. It would be nice to have it as if it actually brought out a new RStudio session with just the inputs that you gave it and stepped through. I'm sure that exists. I just haven't needed to.
Is it an issue of just the fact that R is running everything through your RAM, so they don't want to put too much data at once.
No.
I'm guessing it's like you said, one of those things where if it's to the point where you feel like you would have to do that, you're probably like over.
Well, there are scenarios where you want to debug and you want to see what's happening. I guess I wanted to show you this to have you guys get the feeling for what like creating your own function will do. We very rarely will actually create our own functions, though. It used to be that I used to create a lot of functions. That's partly why this is still in the flow of the program, the syllabus. But the newer tools have obviated that. I still wanted you guys to get that like exposure to what's happening behind the scenes when other people make functions and when you use other people's functions. So yeah.
But like when you assign some things in the global environment, they stick around in the memory, but the functions only ever apply like instantaneously as you're running them, right?
Yep.
So they're not like going to be kind of sticking around.
Exactly.
In the same way.
Yeah.
Cool.
Well, that was actually all the content I wanted to cover today. So, all right, I'll turn off the record.